So my name's Stephen King. I've been doing industrial bolting and sales for about 10 years now. I started off as a wind turbine technician and kind of worked my way up through all that stuff like that. I've been with High Torque for 2 years now. My responsibilities, I do all the global sales and support for all the tensioning line, okay? So any questions on tensioners, it doesn't even matter if they're ones we sell or not. If you're just trying to understand a customer's tools, give me a call. That's what I'm here for. That's my job, okay? So in the past, you know, what High Torque as a whole is trying to do is we're trying to replace older technology. So you got flogging, the hammer wrenches, you've got mechanical torque wrenches, you've got multipliers, things like that. These are all extremely inaccurate. You know, they're just not very good setups, and we're trying to get our stuff in there to replace it. So what we've got, oh, sorry, getting ahead of myself there. Heat induction. We see this especially on the project I just did with you. Those studs are heat induction studs. So they're taking them to a high stress value. And so what they have to do is they don't have a torque tool or a tension tool that can really get up there, so they heat them up. And it's an older technology, but we still see it quite a bit, especially through the Pacific. We see it a lot out in the Pacific.
It's very common.
Yeah. So in the States here, not so much. We don't see it much anymore. The only place we really see it is up north in Canada, like in refineries, or not refineries, but like steel mills and things like that. So, all right, so what we're trying to do is we're trying to get our tools in there. So we've got our torque tools over here, the High Torque tools over here, and then we've got our tensioners. And these are all our detachable setups. So detachable means we can pick it up, we can take it anywhere we want. You can throw it in a crate and move it from job to job, all right? And then the other options we have are permanent solutions, mechanical solutions, like in-place solutions. So right here, what this is a bearing tensioner on the end of a lathe. Actually, I think that's in Australia. A picture right there. But we also got the High Torque nut and enclosure nuts. That's what we're dealing with on your project over there right now. So joint basics, imagine a bolt like a spring. We're pulling up on it, we're putting tension on it, we're moving the nut down, and we're trying to capture that spring. We're trying to capture that collapsing action. So what we want out of all this is we want that spring to stay tight. As far as how the tensioner works, you know, it's pretty simple. You've got a few components here. You've got, you know, a bridge, a cylinder, and a puller. And all you do is apply hydraulic pressure right here. It lifts the stud. You turn the nut down. You let it go. All right? It's pretty simple the way it works. So we've got a cutaway here to kind of show you a little more what the internals look like. So you got your puller right there. You've got your piston right here that moves up and down inside the cylinder. And then you got your bridge and socket down here on the bottom. It's a pretty simple setup. There's not much to it. Tensioners haven't changed much in 50 years. They're about the same. Skip that. So all of our tools, all of our tension tools, all of our torque tools, we operate in this range right here, up to the yield point, okay? Most of our tensioners are designed to go up to 95% of yield, especially our wind tensioners. They're designed to stay within this elastic region of the bolt, okay? Where it's a little different on tensioners and torque heads is you have to be careful on the tensioners not to oversize them. Because if you oversize them, you start dipping into the plastic range. And that's where the bolt, if you look over here, that's where the bolt starts to take shape. It starts to change, okay? And as you push it, it will break. And you can break bolts pretty easy with tensioners if you oversize them, okay? The reason we bring this up is all of our tensioners, whenever we sell a tensioner, it comes with several pieces of documentation, but the main ones are the load charts here and the stress graphs. If you look over here on the side, that red line, that's the edge of the yield region. That's the edge of the elastic region, all right? So you have to be careful not to go beyond that on whatever bolt you're using. So these are color-coded. So your blue one right there, your blue line, that's for an M27 stud, okay? If you see right there, it's possible to rupture that stud. It's possible to go beyond where you need to go. So that's just something we have to be cautious of whenever we're sizing tools for customers, to make sure we don't give them something that's a little too strong, or if we do, we need to let them know, hey, you need to be sure to watch this, okay? All right, so we talked about this just a second ago. We had detachable tensioners, permanent tensioners. So we're going to run through our tensioning line real quick, kind of give you an idea of the type of tools we have available to us. Our standard range of tensioners is going to be these black tensioners you see sitting on the crate right over here. It's our basic design. It's our most economical design. That's a really old design, to be honest with you. It's been around for several years. but there's not much you can do with it. It's pretty basic, but it functions properly. It functions well. The only downside you're going to see on these things is the amount of time it takes to reset the tool and move it from stud to stud. So I don't know if you guys have been through the bolted joint class or if you've done the tensioning part of the class, but if you use those style tensioners right there and you pressure them up to tension your studs, whenever you release your pressure, there's going to be some of the cylinders still sticking out, and you have to retract that manually down back into the cylinder, like you have to push the piston back in. So where you save money, you lose time, okay? But those are designed to fit on all standard flanges, okay, not compact flanges, but standard oil and gas flanges. Those will fit just fine. And we've got reference charts we can make available to you that tell you, okay, if I'm working on a 1,500-pound 10-inch flange, this is the tensioner you need. So it's kind of nice. The cheat sheets are nice. So our next step up is going to be our spring return tools. That's the tools you see right here mounted on the flange. They have more load capability. They still fit just like the black tensioners. They fit on all standard flanges just fine. The upgrade to these is, like I said, more load capability, number one. Number two, they have a spring return feature that whenever you release the pressure, it automatically retracts the piston. So where you pay, say, 30% more for the tensioner, you're gaining tons of time. You're gaining tons of efficiency using these tools right here. Our customers and their technicians love these things because they don't like sitting there winding all the pullers down, especially when you get up into the larger sizes, like the 4-inch tensioners. Those are really hard to wind back down. Our extra loads range, I just want you to know these are available. These aren't stocked on a shelf. These are custom tensioners. And what we've designed these for is for compact flanges or any kind of times where you have a real tight spot on a flange or on a like a vessel head, and you need a high load with very little room. That's what we've designed these for. We're actually in the process right now of adapting these extra load tensioners and the spring return tensioners into one design so it has a removable puller. What makes these extra load tensioners, what makes us able to squeeze it all into a tight space, is we've basically made it a one-piece tensioner. So the piston and the puller are one piece, okay? So by doing that, what we've been able to do is make it more compact. We've taken a lot of that room out of there where we had to make a sleeve and all this stuff. It's made it a lot more compact, but still just as powerful. But like I said, they're custom made. They're pretty much made to order. Our subsea tensioners, we don't do a whole lot with our subsea tensioners right now. It's just not a big market for us. There's a lot of competitors out there that have I'd say probably way more experience than we've got in subsea, and it's just we haven't had a lot of ask on it, and we haven't had a lot of requests for it. I've seen quite a bit in the Caribbean, but I haven't seen anywhere else except for maybe the coast of Africa once. But I just want you to know we do have them available. One thing I wanted you to see on these that it's significantly different than a normal topside tensioner is the height of the tool. Okay, it's a much taller tool, so you're going to have longer studs. Most subsea studs stick out pretty far. Okay. The other thing I want you to notice is it doesn't have a socket. Subsea nuts have Tommy bar holes in the nuts. Whatever they can do to reduce the amount of equipment you're taking down to the bottom, they do it. Okay. So the other thing is the 30-millimeter stroke. Most of our topside tensioners have a stroke of 15 millimeters, but on the subseas, time is money. So what they want to do is they want to get as much out of the tool as they can. So that's when they switch it over to the M30, or sorry, not M30, but 30-millimeter stroke. It's got a lot more pull on it, so they can get it in one shot, and they won't have to reset or anything like that. And then the last thing on the subseas I want you guys to see is that to speed up the process of time, because you've got a long stud, you don't want to sit there and screw a solid puller nut all the way down to the bottom. So what they offer is split nuts, okay? So these things are pretty awesome because you just slide it down the stud to the bottom, click it together and make a couple turns and you're locked in. You're good to go. Now, the convenience, you lose a little bit of duty cycle on these. They're only good for about 5 to 75,000 or 7,500 loads, okay, before you really need to start looking at it and replacing pieces and parts. But they will save you a ton of time. That's actually an old Tintic right there. So we do have subseas available. They stock, we've got them on the shelf in the UK. I've got a tiny bit on the shelf in Texas. If you guys come across anything, feel free to reach out because we'll get something for you. I mean, we don't want to shy away from business, but at the same time, it's hard for us to dip into the rental market on something like this because it's a pretty substantial investment for a rental fleet that we may not use. So. All right, wind style tensioners. So there's two different types of wind tensioners, typically. All right, so you got your multi-stage right here on the right-hand side. All that means is it's got more than one cylinder built into the tool. All right, and then you got your single-stage tool right here. Now, the concept of these two tools was we needed a tool that would fit in a tight space up and down, and we needed a tool that would fit in a tight space side to side. Okay, but we wanted it to have the same load capability. So what we've done with tensioners, you either go up or you go out for your size. To get more power, you either have to make the cylinder bigger or you have to put more small cylinders on top of each other. So these two tools right here, while they look completely different, they have the same load capability, okay? And the reason for this, so this particular the single stage tensioner, which you see right here on the crate with the silver gearbox, that one right there, that's a single stage for a Siemens wind turbine. All right, and the purpose for that was we had a tight space on the blade bearings, and we needed to get in there in a small, short space. We had plenty of room side to side. So that was the purpose of that, was so we can get on the blade bearings. Now you see this multi-stage right here. This is a GE casing tool, but it's the same concept for, say, a blade tensioner. Okay, it's not a blade bearing, but a blade tensioner. And with a blade tensioner, you're right up against a wall. Okay, so you have limited radial space, side to side and all that. But we have tons of room up and down. So that's where they've come in with this narrow tensioner that's real tall, and we can get on tight bolts right there. So the reason I want to tell you this is if we've got tight spots, we can get there. Okay, we can get there. I mean,
that's not an issue. We can make it work.
Yeah, and that's ultimately what I want you to take from this whole thing is if I don't have it, we can make it. Okay, if it's possible, we'll do it. We can definitely do it. We've got some pretty sharp engineers and a ton of experience in other markets that help us in every market. So one thing I definitely want to make you aware of on the wind tensioner, just because it's called a wind tensioner doesn't mean you have to use it in wind. And you'll see that here in a little bit. There's some Japanese civil engineering projects that we use wind tensioners on, like a bridge or on like a steel structure. If it fits, use it. I mean, it doesn't, just because it says wind on it doesn't mean you can only use it in wind. Okay. So just kind of give you an idea of the internal mechanisms real quick. So the inside of a single stage, instead of having coiled springs like these spring returns right here have, they use conical washers. Okay, so you got a washer shaped like this and a washer shaped like this. You put them together, when you squeeze it, it creates a natural spring. Okay, so what they do is they stack these up like that, Belleville washers like that, so whenever it compresses, it'll push back and reset the cylinder for you. So all wind tensioners that we manufacture have the spring return function already built into them. They automatically retract, so you just take them off, put them on the next bolt and go. Inner workings of a multi-stage tensioner, you can see right here, there's a reaction nut, an upper reaction nut, and a lower reaction nut. Both cylinders push on the puller at the same time, and that's what gives you that extra power in such a small package, because you got two cylinders pushing instead of one. Foundation tensioners, primarily you're going to see these only on wind turbines, but we have used them on, say, airplane hangars and things like that. Anywhere there's a foundation, tower cranes, things like that. We've used quite a few of these things. I wanted to kind of show you two different styles of foundation tensioners. So if you look right here on the table on the far left, that's a barrel style. I mean, it's just like an old style foundation tensioner. They work great on 90% of projects, but sometimes when you get inside the wind turbine, you need something a little more compact because you've got too much structure inside, too many. Have you been inside of a wind turbine before, like in the basement? You've got the deck and everything and all the control cabinets, and it's real tight up against the wall. So sometimes those barrel tensioners won't fit in there. You can't quite get them in there. So what we did is we actually designed these elliptical tensioners. So they're real tight, they're real small like this, and instead of having those conical washers around the bolt, what we've done is we've moved it into coil springs, sort of like these spring return tensioners off on the side. And you can see it in the picture right there. You can kind of see the spring right there. There's 4 or 5 of these on each side of it, and that's what helps draw that piston back down. But it's able to put it in a small package where we can get it tied up against the wall. Multi-stud tensioners, typically you're only going to see these on custom jobs. This is for kind of when they want to do something quick. They want to get it done and get it over with. Typically we see it on subsea flanges and manufacturing, like in a factory floor or something where they're refurbishing rotors, things like that. Hydraulic nuts, this is where we're starting to get into our project right now with Toshiba. Hydraulic nuts, they're compact. A lot of times you just leave them in place, and they're like more of a permanent solution. But the one thing I really wanted to get across, like get to you on this one, is if a high torque nut, or if a hydraulic nut will fit there, a high torque nut will fit there. Okay, so definitely let's try to push the high torque nut instead of the hydraulic nuts. And I'll show you some applications here in a little bit where you're going to see a lot of that. You're going to see a lot of cross application where you can maybe get something in there. In our particular case with the closure system, the high torque nut just wasn't feasible. We had too many different size studs and too many tools would be needed. And then you saw what we were able to do. We were able to design the nuts specifically to where they all require the same amount of pressure. Yeah, to do what we need to do. So that's a rare occasion where a high torque nut just wouldn't do it. Hydraulic closure systems, that's what we just talked about. I'll show some pictures here in a little bit of that. Rotor tooling, this is going to be a custom job right here. We really just put this up there to show you what we're capable of. I mean, we can do anything. These particular tools right here, this one on the left right here is for an Alstom turbine, and the one on the right here is for a GE 7FA turbine. They've got these multi-stud tensioner setups, but it's got like 12 or 15 of those in a circle. And they set it on a plate, and I'll show you a picture here in a little bit of what that looks like. Casing tools, I don't know if you've looked out here, we've got these big gray boxes out here. Those are full of casing tools. We ship these out to GE on all their jobs in the United States, and they take their turbines apart and put them back together with our tools. So, engine tool sets, we have a lot of pre-existing designs for some industrial engines that require tensioning on their applications. We've got some Caterpillar designs, and then all these engine manufacturers you've got right here. If you guys deal much with say the U.S. Navy, if you guys have U.S. Navy facilities in your territories, the bottom one right there, the Fairbanks Moors, we just finished that design up, but their new San Antonio class destroyers, they use that. And it's a really nice design. That they have a problem right now getting the tools in the hatch. Like, it's too big. They got a tool ring that weighs like 1,200 pounds. We're able to break it down into 8 separate tools that weigh 40 pounds a piece, and they can haul it in piece by piece. So it's a much nicer setup than what they have. So there's plenty of opportunities out there. If you guys have any kind of naval yards or anything, or any kind of shipping yards in your areas, they're going to have gen sets that require tensioning on the engines. So that's maybe another area. If you've got guys that focus on, industry like that, you can kind of lead them that way. Ultrasonics, we don't have one of these on the shelf right now to test with. I'm working on getting a prototype. I just want you to know that we have it available. We do have ultrasonic measurement equipment available to us through the high torque name. So just know it's there. Every once in a while you'll have a customer that'll want something like this, and if you don't have available through your networks, we can get it for you through ours. Okay. Our pumps, we've got 3 basic pumps. So we've got our air pump right here on the right-hand side. We've got our hand pumps. We've got our electric pumps. Typically, you're going to see the electric pumps more than anything, unless you're dealing with oil and gas, and then you're going to see a lot of air pumps. The beauty of our hand pumps, there's 2 different models available. We've got that little skinny one right there. That's the 1-liter tank, and then we've also got a 2.4-liter tank for a little bit bigger jobs. But in a maintenance situation, those are really handy, because if you got to tighten one bolt, you don't want to have to stretch an air compressor out there, run a hose, or get an electrical cord out. You can just take the little hand pump, go do 1 bolt, and you're done. Our hoses, we have them available in 700, 1,000, 1,500, and 2,500 bar. Typically, you're only going to see 1,500 and 2,500 bar in industrial situations. We can get any hose length, anything you want. Kind of our cookie cutter is up to 12 meters. Anything over 12 meters is going to be a custom hose. It's going to take a little longer because we have to get these plastic covers made to stretch that long. So our hoses are color coded. So typically you're going to see blue, that's 1,500 bar. Red means 2,500 bar, so like the closure system on Toshiba, that's going to be a 2,500 bar closure system. So you're going to see all red hoses, red pumps. So everything we do is color coded on the air side. Green is 10,000 PSI. We usually don't do anything with 10,000 PSI. Connectors and fittings, we've got all kinds of manifolds available. We can do really anything you want. I mean, if you've got a customer, if a customer's got kind of an oddball request, just throw it at us. We'll see what we can do. We've done up to an 8-port manifold before, so we've 1 in, 8 out. We can do shut-off valves like isolation blocks and everything like that. We can do all kinds of really interesting things. The fittings, I wanted to cover that. All of our fittings are CEJN. All of our equipment is CEJN fittings. So there's 3 different types you're going to see in the field as it pertains to high torque. You're going to see the CEJN 115. That's what you're going to see on our torque equipment, the quick connects. Okay, that's 10,000 PSI. CEJ 116, that's 1,500 bar. All the blue hoses, that's what's going to come on that as a 1,500 bar connector. And then on the red stuff, on the red hoses, you're going to see CEJN 125. And that's rated for 2,500 bar. They are not cross-compatible. You cannot mix them, okay? So if the fitting doesn't fit, look at the number, and you'll see it here in a minute. When you come up here, you can see the number written on there and the rating written on the fitting itself. All right. Is there any questions on our products so far? Did I go too fast?
No, sure.
Okay. All right, we're going to get a little application data here. Tensioners are used all over the place. Pretty much anywhere where we see torque equipment, we're going to see tension equipment. So oil and gas industry is probably our primary customer for tensioners right now. Wind is a close second. But anywhere you got flanges, refineries, petrochemical, any of that stuff. Tensioners are used in there every day. If we can't get them pushed over to torque, then we've got tension available to the customer, whatever it takes to get their business, you know. Subsea, like I said, we don't get into subsea too much, but it is available. It's a market I would definitely like to get into, but we need more experience. We need more people with a little more experience before we really get too far into it. But we do have the equipment available for purchase all day long. We size it from 3/4 up to 3.5 inch, and we can do metrics as well. We've got solid nuts, split nuts. We can give them kind of a economic package and a more expensive package. We can give them, you know, different options. So I wanted to show you this right here. This is our subsea pump right here. It's an all stainless construction, so no corrosion, anything like that. Plus it has a much larger tank on it than our standard air pump. It has a 15-liter tank on it. Anytime we do a quote, we always throw in a hose. We want to quote a hose reel as well, because I don't know if you guys have done much subsea, but you get all that hose up on the deck and it's a big mess. You're tripping over it. Yeah. So we like to get that hose reel on the quote as well. Downlines come in we've got pre-cut links, and then we can do custom links. But our pre-cut links are like 50 meters, 100 meters, 120 meters, 200 meters.
Typically, how many divers would be required for such a?
It just depends. Usually, the three or four is what I've seen. You got 3 or 4 guys working at once. Usually 2-man teams. You know, you got two guys on one side of the flange, and if they've got another flange like sitting right by. But I've seen anywhere between 2 and 4, and I've heard of like big jobs where they've got a bunch of guys in there doing a bunch of stuff, but I haven't seen it. So heat exchangers. This slide, I more want to just show you, like, we have the equipment available to do heat exchangers. This is a perfect opportunity for a high torque nut or for a washer right here. But if they're just dead set on tensioning, we can take care of you with the tensioners. We've got tensioners that'll fit just about any flange out there, or if we don't have it, we can make it for you. Just depends on how critical the job is. You can see right here, they've gone a little overboard with the hoses, but that's what 100% coverage looks like right there. Rarely do we see them all on one side of the flange. Usually when we do 100% coverage, it's on either side of the flange. But since on a heat exchanger, it's going to be a blind flange, so you're stuck with it. High pressure pipes. This is probably our biggest market as far as tensioning goes. As far as topside tensioning goes, we do a lot of pipes. We do a lot of pipe work, and especially in refineries and power plants. Pressure vessel covers is kind of like a heat exchanger. Manhole covers. if you guys have any solar projects out there, they actually rent quite a few tensioners to work on their main structure where all the preheater and everything's at. We've had a lot of solar plants recently that started tensioning their manhole covers instead of torquing them. So, and those are big tensioners. They're 3.5 inch, 4 inch tensioners. It's big stuff. So there's several different options. Like a basic rental or a basic sale would just be standard tools like these black tools or like the spring returns. But we have had customers ask for these multi-stud tensioners because they just want to get it all knocked out real quick. Wind turbines, this is our second biggest market as far as tensioning goes, just because every wind turbine uses tensioning in one place or another. Even GE, which has traditionally been an all torque setup, their foundations are tensioned most of the time. Very rarely do you see a torqued foundation. We'll get a little bit more into the wind turbines here in a second. So steam turbines, this is the rotors and everything like that. This is a plant down in South America where they rebuild GE rotors. They use tensioning to assemble the rotors coming up. And so we've actually got custom tooling already made for that. We don't need measurements or specs. We've already got it. So if you guys ever come across something like that, give me a call because we might have something already on design. It's kind of like that closure system. We already had most of that stuff. We just had to figure out how many hoses we need, basically. Steam turbine, here's a picture of that closure system right there. They link it all together and they run somewhere around 30 or 40 tools on one pump. And they're able to isolate it and pull the pump off and do whatever work they need to do and then come back. So, hydroelectric, we do this quite a bit actually. We're working on several projects right now at hydroelectric dams all throughout the West Coast right now. What I want you to know on this is anytime you deal with anything that touches water supply, it has to be stainless steel, okay? So that requires a lot of custom work. So if you come across a hydroelectric project or anything like that that requires a stainless steel type tensioner, it's going to take us probably 6 weeks at a minimum to manufacture something for you, because we have to do a lot of metallurgical studies to make sure that stainless steel is soft, super soft, especially when you're tensioning with it. So we have to design something with a really thick bridge on it so the footprint stress isn't too high, because if you make a bridge really skinny and you give it too much pressure, it'll crack or deform. So we have to give it a lot of meat on the bottom on stainless steel. Same thing with a puller. We have to make the puller really fat in the center so it doesn't pull the threads out. So wind turbine applications, most of the tensioning you're going to see is up in the nacelle area, your blades, your rotor, and things like that. But we do have some towers that require tensioning in the center, on the flanges, and then, of course, foundation bolting. So we have a massive list of pre-existing designs, okay? So there's a lot of wind turbines out there. You can just call me, hey, I'm working on a Vestas V82, I need a quote. I can put a quote together in less than 30 seconds for a Vestas turbine, because I know exactly what they need, okay? Now, if you come across a model we've never seen before, like there's some Chinese models we don't have specs on. If we need specs, I'll let you know, and we'll go through that when we go through our bolt surveys, kind of the information we need. But I want you to know that we have a lot of pre-existing designs already on a database. You don't have to worry about getting a quote out fast enough, because we'll be able to quote you really fast. So just some typical places in the nacelle you're going to see tensionings on your blades, your blade bearings, your bed frame, sometimes on the frames, like on a Mitsubishi that's tensioned, on a Acciona that's tensioned. Your main bearings on your gearbox and your main shaft on a Vestas that's tensioned. We have a custom tensioner already designed for that. It's on ITH and High Torque are the only two companies that have a design for the Vestas main bearing. So that's something we have available. We keep them on the shelf. So if you ever run across something like that, we can get it to you a lot faster than there's no manufacturing time, no lead time on stuff like that. Going down the tower, like I said, very few towers tension. Most of this is torque applications, but just so you're aware, Acciona 3000 and the Mitsubishi 2.4s, those are all tension on the flanges, okay? And then, of course, foundation tensioning. You can see, I wish we had a picture of the inside, but it's really, they're dark on the inside. It's hard to get a good picture. But You can see how tight the studs are against the wall right down. Now put that on the inside and put stuff on the other side, and you can see how tight it gets on the inside once everything's put together. But also another thing, foundation tensioning. The longest hose you can get is what you want. So usually we recommend a 10-meter hose because you can leave the pump in one place and work your way all the way around the tower with that. Okay. If you give them a standard 5-meter hose, they're going to have to keep moving the pump. Yeah. So we've done a lot. Some of our partners in the UK have done a lot with mining. I personally haven't done a lot with mining. I've just done a little bit with some Lee Bear mining equipment on the tracks. But they've got a lot of application data already on a lot of these mining machines. So if you guys run across something that needs tensioning and we can't get a high torque nut or washer or one of our products in there, give me a call. And our guys in the UK might have what we need to get you guys going. So that's a perfect example right there of a good place to put a high torque nut if you can get it in there. Anywhere you can get a hydraulic nut, you can get a high torque nut. There's a crusher right there on the corner on the feet. We see this a lot, especially on gearboxes and steel mills. We're starting to see a lot of tensioning on the feet. We've had a lot of guys, especially down in Alabama, they've been successful getting a high torque nut on those instead of tensioning them. Armor face conveyors. I've never seen this equipment in person, but I've heard it's huge. Yeah. Some shipbuilding, like I told you earlier, we've done some work with the U.S. Navy. We've done quite a bit of work with the shipyard in Baltimore on tensioning like slew rings on their cranes that are built into the ship and everything like that. But we've also done propeller nuts to hold the big propeller on the back of the ship, everything like that. So there's a lot of custom applications in here. We've tensioned barges together to sit cranes on them. There's all kinds of areas where we can do work. So right here, just kind of show you some different projects. We did a suspension bridge. We used some tensioning on their guide cables and everything like that. And then right here on this, that's what I wanted to show you. That's where we used a wind tensioner on a non-wind application. You know, if it fits, use it, okay? But we want you to know that it's available. So if you've got a tight spot, that's what you want to look for, is something like that. Something that's narrow and tall. You know, we've got it available. If it looks tight and don't just think, oh, I can't do anything with this, because a standard tensioner would not fit onto something that small. You know, we would have to use a multi-stage to get in there. But just know that it's there. We've got the capability. All right, conducting a survey. This is basically the nuts and bolts of it. This is the information that I need or we need to properly quote a tool to a customer. So what we've done is we've gone through and redid our quote sheet. We redid our measurement sheet, basically. We've had 3 or 4 floating around. What we've done is we've taken all the information that we've learned from those in the past and we squeezed it into one sheet. And we've got it narrowed down to 5 critical questions that we want answered. So if you look over here on the right, that's our new checklist for tensioning, okay? And we separated into 5 areas. We need to know about the bolt. We need to know what kind of load you need. We need to know the nut, the information about the nut, okay? And then we need to know about the bolt spacing. So if you're dealing with the flange, what kind of spacing you've got on the flange. And then the space envelope. We need to know the measurements around the stud. Like we need to know how much room you have, how much room you have here. We need to know all the information so that we can properly select a tool to fit on there, okay? So if you go down through this list right here, I don't know if you can read it or not, but bolt data, it's just asking for the diameter, the thread pitch, and the material. Those are critical pieces of information because that tells us more than those little 3 pieces of information tell us a lot. Okay, they tell us effective area, you know, potential length and stuff like that. I mean, it helps us calculate yield and things like that. So the next line is the load data. So load data can come in 2 different forms. You'll have an actual load number or you'll have a percentage of yield. Okay. And the reason why we need to know the first little bit of information is because if they say, well, I want to go to 50% of yield, well, we have to know the diameter and the bolt material to determine what the yield is. Okay? So say a typical B7 stud under 2 3/4 inches. The yield on that's 105,000 PSI. Okay? If it's a 2 3/4 or a 3-inch, then it drops down to 95,000 psi. So that's the reason why we need to know bolt material and bolt size, because that will tell us information we need to know as far as load characteristics. So load data, you can give it to me in any format you got. You don't have to convert it to kilonewtons or pounds of force. That's what we've got on here. If they give it to you in decinewtons, whatever they give it to you, I'll convert it, okay? I'll make it work. So just get whatever information you can get, and if it's too cryptic, then I'll call you or I'll send you an email and ask you to be a little more specific, okay? But just get as much data as you can. All right, nut data, the reason why we put this on here, I mean, there's the obvious ones. We need to know the size of the nut and everything like that, but there's things we have to take in consideration. Is the nut taller than a standard nut? If it is, we have to make more room in the bridge of the tensioner to fit that nut in there, okay? We have to take a little bit off the puller to fit that in there. So we need to know as much information about the nut as possible. Is it round? Does it have Tommy bar holes on it? If it does, how high up are they? Because we need to know that so we can cut out a big enough window on the tensioner to get a Tommy bar in there. So this is just all information we need to know. And sometimes you'll come across stuff like this right here. You're like, oh, it's just a standard nut and a standard bolt. Well, that's fine. That's all you got to tell me. Just tell me what grade it is and what diameter it is, and we can go from there. But this is really critical when we start getting into the more customized things. Like, for instance, the quote you sent me the other day, the request you sent me the other day for the multi-stage tensioners, the M70, the M64, the M100. Well, on the bigger stuff, that's not a standard design. That's something we have to customize. And so that's when we start needing information on the bolt and the nut, and if there's a washer underneath it. We need to know all this information so we can make you a tool that fits. Okay? Because especially being, where you guys are located versus where our manufacturing facilities are, there's an added week of time at least in shipping. And so if we make a mistake, if we don't get all the information and we send the customer the wrong tool and they take it, especially with you, they take it out in the middle of nowhere, they're going to have to bring it all the way back to you, and then it's going to take another week to send it back to me, and then it's going to take us 2 or 3 weeks to fix it, another week back to you, another week out. I mean, you're talking a month, 2 months for a mistake that we could have fixed if we would have got the right information the first time. Up here on load, they asked residual and applied load. I wanted to kind of get, I don't know if you guys know the difference between the two, but I just wanted to touch on it real quick. Okay, on a tensioner, it's got a little bit of give in the bridge, okay? It's called load transfer factor. When we start calculating pressures and things like that, we have to take this into account. It's basically the inefficiency in the tool and the flange, okay? It's that little bit of give that everything's got. Whenever we let go, it relaxes out and we lose a little bit of tension. So we have to give it more than what is required to make sure it gets what it's required, if that makes any sense. So your residual load is how much load they want left in the flange. Like, so if they say they want to load it up to 500 kilonewtons, we need to tension it to 500 kilonewtons. We're going to have to give it about 20% more probably to get it there. So your residual load is always going to be lower than your applied load. And we determine this number in between is determined based on grip length, based on the flange characteristics and things like that, and the type of stud, things like that. And this is all stuff we can help you with on the backside, okay? We want you to know that it exists, okay? So if the customer ever tells you a number, you need to know whether it's the residual load or the applied load, because the applied load's always going to be a little bit higher, okay? So if they need it at 500, we're going to have to do it to, say, 550 so that it relaxes down to 500. So think of it like the spring. You're pulling out on the spring, and you move, the nut down, and then when you let go, it's all going to relax a little bit. Well, not just the bolt relaxes, but the flange relaxes and the tensioner relaxes. So we have to make up for that difference.
It's like a creep.
Exactly. Yeah, it's very similar. Yeah. So grip length. If you look at our sheet over here, down here in the space envelope, it's letter A. It asks for the thickness of the flange. And then what we're trying to capture there is we're trying to capture how long the stud is. Because the shorter the stud, the more we have to pull it. The longer the stud, the less we have to pull it. It's a elasticity thing. A short bolt, think of like a short spring. If you've ever tried to pull a short spring apart, it's really hard. But if you ever try to pull like a spring door, a screen door spring apart, I mean, it's simple. I mean, it's just stretchy. So we need to know this number to know how much extra we have to give it power-wise to compensate for the length. So the easy version of it is we need a measurement from nut to nut, inside of the nut to inside of the nut. Now it's not exactly precise, but it gives us a ballpark. It gets us in the range we need to be to size a tensioner. And then once we get closer to load calculations, then we can be more specific with the grip length. But if you can just get us a rough measurement between the nuts, or in the case of a blind flange, from the top of the bottom flange. So say if this was a blind flange right here, we need to know the distance from here to here, okay? And that'll help us size the tensioner properly for you. Additional considerations, things we need to know, like if it's out of the ordinary, if you're in a hot environment, if you're in a moist environment, a lot of humidity, anything like that, we need to know information like this so we can make adjustments to the tool design, or you know, if you're working in a super hot environment, we'll have to change the seals for you. You know, we've got seals that are high temperature seals that cost quite a bit more, and there's no reason to put them in all of our tools. But if we know you're working in a hot environment, we can put hotter seals in there, basically. But we need to know different environmental conditions. You know, if you're working upside down 300 feet off the ground, we need to know stuff like this, you know, so we can maybe design a safety feature into the tool to help them hold it on the flange. Or, you know, so any kind of information like that's really handy. You know, what I would call a standard situation is this, you know, this or working inside of a wind turbine, that's standard to us. That's not out of the ordinary. But if you start throwing in, you know, upside down flanges 300 feet off the ground, then yeah, it'd be nice to know that stuff so we can maybe help you with the design. We can have suggestions to make it better and also help sell the tool. When you're quoting tools, you know, they'll come to you and say, hey, I need some tensioners. Same thing with torque tools. Always ask them, hey, well, do you need a pump? Do you need hoses? Things like that. Our hoses do not come with the pump. On tensioning equipment, hoses are purchased separate. But always go for the accessories, you know, always go for the upsell. Custom tensioners, I wanted to run through this, kind of give you an idea of what we do when you guys come to us with a request. So basic request, we try to fit a standard tool on there. Okay. If the standard tool doesn't fit, then we go the next level up. So level 1 is when you have a custom thread pitch that's non-standard. So like in M45, the standard, or M42, the standard thread pitch is 4.5. We have a lot of people that come to us M42 by 3. Well, that's non-standard for us. So that's the next step up. It takes us a couple weeks, but what we do is we drill you a new puller out. So it takes about a week to do it. We pull one off the shelf, send it through the machine shop, and get you out the door. So standard tool would be an M42 by 4.5 tensioner. You know, we've got those just sitting on the shelf. Here you go. That's 0 lead time. So the next stage up, you know, level 1, you're looking at about a week to 2 weeks. And then the next step up from there is if we have to start modifying the bridge, if we have to make the bridge taller, shorter, because you're actually machining that out of a blank. I mean, that's not something we can't pre-machine something and then add a little to it later. So that's a little more custom. It takes, you know, 2 to 3 weeks. And then if we can't do it from there, that's when we start stepping into custom tool design, and you're looking at 4 to 6 weeks minimum on that stuff, unless it's a predetermined, like a design we already got loaded in our system. There's a good chance we have it on the shelf. You know, there are some things that have been custom in the past that are now standard. So for instance, like the Vestas M64 tensioner, that used to be a custom tool only. Now that's a stock item. We keep them on the shelf. So if you run into an oddball situation, don't shy away from it because it looks like it's going to be a lot of work, because we might already have something for you. Just kind of give you an idea of some of the custom stuff we've done there. That's an example right there of a tool that was customized that we ended up making a standard tool, our elliptical foundation tensioner. They were so popular, we actually made a bigger model so we can cover 75 KSI and 150 KSI foundation studs with that elliptical tensioner now. So, and they're actually pretty cheap.
Okay.
Yeah.
So it's economical. Wow.
Yeah. I mean, $3,800 for a foundation tensioner is pretty stinking cheap. Yeah. So, and then the big model is only like 43. So, this is an example of a custom project we did. We worked with High Torque Rio. This is for an API 6 flange, super compact, 7 1/16 inch pipe with like 24 or 16 2-inch studs. I mean, you're talking about a very large stud and a very small flange. And so this is an idea of this is for a subsea company. They drag the pipe up off the ocean floor and they throw this multi-stud tensioner on there. They knock it out in like 15 minutes and then drop it back down on the floor. I mean, it's real quick. it's fast. But stuff like this gets expensive because there's a lot of machine time and there's a lot of engineering time that goes into something like this. But this is just to show you that we're capable of a lot. I mean, we can do a lot for you, and this project didn't take long at all. I mean, we knocked this project out in like 4 or 5 weeks. So, all right, bolt tensioner limitations. You know, there's some places that you know, if a customer comes to you and they want to tension something, there's a lot of places a tensioner doesn't belong. You know, if they come to you with a previously torqued application and they're wanting to tension it, you know, we have to look at the feasibility of it. You know, we can't tension a cap head screw unless you can get on the other side of it, but most of the time cap head screws are in a blind flange. You know, on this bed plate right here, they wanted to put a tensioner on that and tension it. We couldn't get on it. I mean, we can't ask them to cut chunks off their machinery to fit our tools in there, and we can't design a tensioner that'll fit underneath that. But a Stealth will fit right on there just fine, you know.
Get that a lot.
Yeah, we get people that think, well, I'm tensioning all this other stuff, and they only torque one thing, and so they're like, hey, well, let's tension this too, and I'm like,
It's not feasible.
it's not worth it. It's, you know, the cost of the tooling versus, you know, do you really need it? You know, we have customers that their engineers require that they tension, like for instance, this one right here, this was an M8 bolt. M8 bolts are just microscopic in the tensioning world, and their engineers wanted to tension it. And so we designed the tool for them, and we advised them the entire time, hey, just torque this thing. But they wanted a cost, so we gave them a cost on a tool, and it was between $2,500 and $3,000 for the tool when they could have just used a little $50 clicker wrench and got it over with real fast. So sometimes it's just not worth it.
Sure.
Previously torqued applications usually don't have enough thread protrusion to get a tensioner on there. We have to have at least one diameter of the stud sticking out of the nut to get a tensioner on there safely. So their options are either to put a longer stud in it or torque it. You know, and normally we just say, hey, torque it. You know, there's you'll come across some situations where previously tensioned applications, they chop the stud off, not thinking. I've seen it a lot on wind turbines. They'll do the wind turbine foundation and they'll come by and knock 8 or 9 inches off the stud because they just stick up too high. It looks ugly or something. They can't tension a stud that's too short. You know, you cannot get a tensioner on that, and they'll end up having to torque it because otherwise they'd have to tear the wind turbine down and put a new foundation in, and that's just not cost effective. High temperatures, this is a prime example of where we could get a high torque nut into an application where a tensioner would fail. I was just talking with Chris this morning. There's some hot bolting applications in the ASME book. You know, if you're running through that ASME book, there are some, you know, whenever they hot bolt the flange, it's between 150 and 230 C. You know, our tensioners, if you look right here, even our high temperature seals, they're only good to 200. You know, and that's not saying the bolt, whenever you bring up your process to 230, that doesn't mean the bolts are 230, but there's a chance you could damage the tensioner. You know, tensioners are only rated for so much heat, and then they just don't work anymore. The seals fail really quick in high temperature applications. And even our high temperature seals, if you were at the upper range of that hot bolting application, our high temperature seals won't hold up to that. So this is a great place where you could possibly get a high torque nut in. Weight. Tensioners are heavy. Tensioners are extremely heavy. Even the smallest tensioners are heavy. When you start getting into large bolts, anything, you know, really 3-inch and up, you're talking 100 pounds per tensioner. And there's a lot of applications where you could get lucky and get say a Stealth or an Avani or something in there that could take its place that's a lot lighter. This is an example of a heavy tool that we had to make for a customer. This application right here, it was out in the field and they had no way to get an overhead crane in there to help them lift the tool. You can look at the tool weight over here. It totals up to a little over 120 kilos. That's heavy. Yeah, that's heavy. So we ended up having to install handles on the side of it so they could team lift it. Okay. The main body is 50 kilos. Just the cylinder part of it was 50 kilos, and it's just too much for somebody to handle. You know, that's a good spot where, you know, you could say, well, hey, this tensioner is going to be way too heavy. What do you think about torque? You know, be a good spot to try to get that stuff in there. Apply load. This is really right up Cliff's territory right here on this Toshiba steam turbine. On the older steam turbines, they used induction heating on the bolts, so they used a lighter material the stainless material,
Yeah.
and they ran it to a really high yield with heat, and they were capable of doing that without going over the yield limit. So they were able to tighten it up with cheaper studs, basically. They have more heat, fluctuation properties in them. So a tensioner cannot do this. Once you start getting into a high load transfer factor, so short studs, once you start getting into short studs or getting into something with a high yield or with a high load on it, tensioner really isn't advisable, because we're either going to have to add spacers in there, which means they're going to have to elongate their studs, which is going to cost way too much money, or we're going to have to use heat induction. So this is a great place for a high torque nut, or just tell them to use their old technology to tighten the bolts up, because a tensioner is just not advisable. We're actually running into this quite a bit lately. As time has progressed, the loads keep getting higher. The stud, they're not changing the studs, but they're just getting more and more and more on the load. We had a refinery last year that we did the service on, and they went to 55% of yield. This year they went to 75% of yield, and they're using the same studs. So everybody, they just keep getting tighter. They just keep getting tighter and tighter, and eventually you're going to hit a point where our tensioners, we aren't going to be able to fit something that big in the space that small. So, all right. So the safety on tensioning is very similar to the safety on torquing. There are some differences, but mostly it's similarities. Okay. Differences are your pressure. We're dealing with 10,000. We're dealing in torquing, you're 10,000 psi. Tensioning, you're doing 22,000 psi normally. 2,500 bar systems, that's almost 30,000 psi. So a high pressure leak causes a little more damage at that pressure than it would at say 10,000. So we just have to be really cautious with what you're dealing with, and just understand that it's basically a contained explosion. So you got to be careful with it. Okay. Everyone's responsible for everyone else's safety. If Alvin sees something wrong that I'm doing, he needs to tell me. He needs to stop me. Okay. Everyone has the right to stop. Always read. Every tool we supply, if we send out 10 pumps, we're going to send out 10 manuals. Okay. We supply manual with every tool we send out, with the exception of the hoses, because that's part of the, it's somewhere in one of the manuals. But for every tool or pump we sell, it's got a manual with it. And a lot of times customers will just toss it. There is a lot of valuable information in there. They tell you how to store the tools. They tell you everything about the tool. And there's a considerable safety section in there that and it has a lot of pictures. It's really easy to read. It's really easy to follow through it. Recommend to the customer that they read it. I recommend that one of you guys read it. Whenever you have new tools come to your territory that you've never seen before, just look through it real quick, because you're going to find something in there. It tells you, how much max stud protrusion. It tells you all kinds of information. It tells you max pressure on the tool. It tells you everything you need to know about the tools. Okay? So read the manual. And if you ever have a question, call me. If I don't know the answer, I will find somebody that does, and we'll answer it as quick as possible. Again, we're dealing with high pressure hydraulics. A high pressure rupture can cause some serious damage, can even kill you. Okay? So just be cautious of what you're doing, and be respectful of the tools that you're working with, all right? We're dealing with high mechanical loads. A lot of these tools, even this little tool right here, will do 200,000 pounds of force. So a lot of power in a small package. So we have to be very cautious around the equipment while we're using it. Anytime if you go over on your pressures, you could damage the stud, you could break a stud, you could launch a piece of the tool off. I mean, it just, be really careful with what you're dealing with. Never stand in the bolt axis. So if I'm tensioning, if I'm running this up with pressure, I don't want to stand in front of it, because when it fails, usually it fails when you're giving pressure. Okay? If it were to fail, it would fail while you're coming up on the pressure. So if you're standing in front of the thing and the stud breaks, that puller is going to pop out and hit you. Okay? You don't want that. It hurts. Typical safety equipment is just what you see on a normal job site. We like to see steel toe boots. We like to see, glasses and gloves. Some sites will make you wear hard hats. Some sites will make you wear a safety vest. There's some sites, especially in the UK, you have to, anytime you're dealing with hydraulics, you have to wear overalls. You have to wear coveralls. So clear the area of any non-essential personnel. I mean, you don't want a bunch of people standing around watching you tension. It's just the less people, the better. You need, yeah. So Position the pump far away from the tools, as far away as possible, where you can still communicate. Though the reason for that is that to the pump operator, if something goes wrong with the tools, they don't need to be in the line of fire. They need to be able to drop the pressure as quick as possible. So that's why you want to put the pump away from the area. You don't want it sitting right underneath the flange when you're tensioning. Okay. If required, set up barriers. We've seen that a lot, especially in refineries. You put up a barrier, just say, hey, keep out while we're doing this. It's kind of the same idea as welding. You know, they put up the tarps and say, stay away. So, don't leave tensioners pressurized on the flange. If you pressure something up, do what you need to do and drop the pressure off. Because if you leave pressure on there and you walk away from the scene, if somebody walks up and grabs the hose, they could get hurt. You know, they could break it and cause some kind of damage. So when you're pressurizing the tools, everybody needs to stand back. You don't need to have somebody standing right on top of there trying to tighten the nut as it's coming up on pressure, okay? There's gonna be some situations, like say in a hub on a wind turbine, when you're tensioning blades, you're not gonna be able to get far away from it, but try to at least shield yourself a little bit. There's a lot of components like the pitch ram and things like that inside the wind turbine that you can kind of put between yourself and the tool. But especially on flanges, you know, step back while the pressure's coming up. Let the pressure get up there, and once you reach the pressure, your target pressure, then you can step in and do what work you need to do, okay? And again, always keep away from the axis of the bolt. Try not to stand in front of it when you're tightening it. Try to stand to the side of it. And don't grab the hoses and move them around while they're pressurized. Same concept as a torque setup. All right, limit your pressure. This came back to that pressure graph I showed you at the very beginning, okay? There are some of these tensioners have the capability of yielding the bolts that you're tightening. So if you know at 700 or 800 bar, I'm gonna yield an M27 stud, and you're working on an M27 stud, you need to dial the pressure back. You need to preset the pressure on the pump so that it cannot exceed that number, okay? And as you work, it's, not as much with the air pumps, but the electrics. One thing I haven't touched on yet this week was on the electric pumps, as the fluid heats up, that the pressure changes, okay? So you need to constantly go back and check your gauge to make sure you're still on your number. Don't work all day. Don't set it first thing in the morning and then work all day, because when you come back, and it's the same thing on torque pumps, you come back and the pressure is dropped because the fluid is thinned out. So check your application, make sure you've got enough stud protrusion. If I'm working on this stud right here and it's only got 4 threads hanging out of the top of it, you can get a tensioner on it. It's not going to go well though. I mean, as soon as you pressure it up, it'll rip the threads right off of it. So make sure, the easiest way to look at it is just, if you don't have a gauge, is just measure the nut with your thumb and stick that up there and make sure you've got, you know, enough room on there. You can use your finger to measure it real easy. Do's and don'ts. Tensioners are heavy. Don't pick up the entire tool. Once you start getting into bolts, especially over 2 3/4 of an inch, the tools weigh 70 or 80 pounds a piece. Okay, try to. I mean, the puller comes out, the bridge comes off. You know, be careful. You'll tear your back up pretty quick if you're moving a bunch of 100-pound tools around, especially when you're taking them in and out of crate and you've got to hold it up on a flange. You know, a lot of our heavier tools, they come with an eye bolt installed, so you can use a winch on them. You know, whatever makes the job easier and saves your back, but just be careful, because if you drop a 100-pound tool on your foot, it doesn't matter if you've got a safety toe or not, it's going to cause some damage. The hoses are not handles. Please do not pick a tensioner up by the hose, okay? Don't carry it around like this. It causes so much damage to the hoses and can cause some serious damage to you if you pressure it up. Last one on that slide, if you have a high pressure, if you've got a leak, if you start pressuring up the tool and you notice a drip coming out of your tool right there, don't just grab a wrench and tighten it up, because you're going to create a high pressure stream when you do that, okay? So it's going to take it from a drip to a razor blade, and it's just going to slice through whatever it can. So make sure you depressurize the system first, fix the leak, then pressure it back up, okay? Don't ever try to tighten up a leaky fitting while it's being pressurized. All of our tools have a stroke indicator, a max stroke indicator on them. You see a little red ring on the slide right there? On our spring return tensioners, it's yellow. On our regular size tensioners right there, that's red. All of our wind tensioners, it's red. Red means stop, yellow means stop. And anytime you see that ring pop up, they need to stop. because if you push it any further, you're going to cause a leak, and you're going to cause a failure, and you're going to have to reset the whole system and start over. So if you have 8 tensioners tied in a circuit, right, and one of them leaks, you're going to lose pressure in all your heads. So if you get anytime best way to prevent this is to make sure your tensioners are screwed on the flange, okay? If you've got your tensioners screwed all the way down, you shouldn't have a problem with overstroke unless you've got something wrong with your studs. So when you're pressuring it up, just have somebody keep an eye on it and just look for color, okay? You look for yellow, look for red. If you see either or, yell stop, and we'll see what's going on, okay? Hydraulic connectors, it's not good to pressurize open hydraulic connectors. The reason why is it's just a simple little mechanical valve in there that if you put 1,500 bar of pressure on it, eventually it will fail and it'll blow out, okay? So what we do is if you ever have to pressurize a system or a pump with an open connector, let's see if I can pull it out here. We have plugs available, okay? So it's just a simple plug. All the air pumps come with them. You just snap it in there and it completes the circuit, and you've got a metal on metal seal. You don't have to worry about a hydraulic burst. All right, hoses, inspect your hoses before you use them. The best time to inspect them, honestly, is when you're putting them on, because you can see them right there. This clear coating right here is a safety feature. If you have a high pressure leak on the hose, a lot of times this will redirect the flow so it doesn't actually go through the hose. It'll actually hit this shield and run down the hose. So it's a little added safety feature. It looks simple, but it actually has a purpose. If it's missing, we really recommend replacing the hose. If it's cracked or damaged, if it's simple crack, put a little piece of tape on it, okay? If this is damaged, this outer, it's not that big of a deal. But the big deal is if anything in this blue part right here is damaged. If you see pinch or if you see any kind of metal showing, that hose is out of service, okay? Take it out of service. Also, our hoses have a minimum bend radius. If you bend it too far, it will kink and blow out, okay? So make sure you don't have a customer. The other thing is keep your hoses clean on the floor, and that's another reason to keep your area clear. If you have a customer, if you have somebody roll a cart over a hose while it's being pressurized, it could possibly damage the hose and cause a high pressure leak. So keep your area clear so nobody's tripping over hoses and things like that. Do not exceed the max working pressure of the hose. We say that over time, if you were to go to 1,600 bar constantly on a 1,500 bar hose, eventually it will wear out faster, okay? But don't think that our hoses are you know, as soon as you hit 1501, it's gonna explode. These hoses are actually tested to a high burst pressure. It's somewhere around 60,000 PSI. So we're good for 3 times what the hose is rated for. It's not fragile, but the more you push it, the faster it's gonna wear out. All right, any questions on safety, anything like that? All right. All right, if you guys will grab some glasses and some gloves off the table back there, we'll do a little practical. So it's just some basics for you here. Whenever you're installing a tensioner on a flange, and I hope Chris showed you guys this the other day, whenever you did that bolting class, but whenever you're installing tensioners on a flange, it's always good to put your thumb in the puller. It helps you keep from dropping you know, you don't want to drop it on your foot. Yeah, fair enough. So if you put your thumb in there, it actually helps you line it up, and then you just turn it like that, okay? Okay. So that's a really handy, just kind of in the field fix that a lot of us picked up. But Chris is actually the one that showed it to me. So the other thing when you're lining up tools on the flange, you want to make sure your windows are facing out, okay? So you want your windows facing out so that you can get to it with the Tommy bar, okay? Because if they're facing in or over here, you're not going to be able to get on it, all right? So say we've got all the tools on here, we've got all our link hoses hooked up, okay? We've got it hooked to the pump. You want to make sure there's no interference between your couplers and everything. You want to make sure you can see your windows. See, like this one, we can't see the window on. So now I can see it there. All right.
Well, in terms of the tightening, how much force do you use?
Just hand tight. Hand tight, yeah. Just touch it down and give it a little snug, okay?
Okay.
And the reason that snug helps is if you have to manipulate your hoses or move them around, it'll keep from turning the tool. Okay. So for instance, like this one right here, I need to move the hose around a little bit. It's going to move the tool, but if I cinch it up, then I can
Okay, I see what you're saying.
manipulate the hose without turning the tool. Okay.
And then the windows on the bottom?
The windows are on the bottom, yeah, like right there. Because the reason why we do that is because like this is the blind flange, you know, so you got all kinds of room right here. So theoretically, you could move the bridge, you could move the hole to the inside to make it easier. But if you've got a pipe right here, you know, it's good to just follow the same technique all the way around. So we've got good engagement on all the studs here. We've got all our hoses hooked up. We've got that blind plug in the end of the hose there. So I've already got our pump set, but just so you know, whenever you're setting a pump, always work from the bottom up, okay? So start, not necessarily at 0, but start from the bottom and work your way up to your target pressure. Don't bring it down to your pressure. You know, always adjust up, okay? So let's say you need to determine your pump pressures and everything like that. That's something that we'll cover, you know, later on. Not today probably, but I'll help you guys with pressure calculations in the future on figuring out what pressures you need, like your A and your B pressure. I've got some really good spreadsheets that I can send you on all of our tools. Okay, so on our electric pump, it's just like our torque pumps. We've got a little valve, turn the knob right there to set your pressure. Okay, it's real simple, and you got a remote. So if you guys will back up just a little bit, I'm going to set the pressure real quick. We're going to set it at 500 bar, okay? So you want somebody watching the tools to make sure you don't see any overstroke indicators. All right, so we got to our pressure. And we'll turn the pump off, and now that we're up to pressure, we can approach the tools with the Tommy bars. So if you'll just tighten the nuts. Yeah. So you're going the wrong way. There you go. Just until it touches. That's the thing. That's one thing that's nice about careful with the hose there. It's just one thing with tensioners is, you know, just touch it. Just touch it down. You don't have to really torque down on it. The tool's doing all the work for you. Some of these, I think the threads are a little chewed up on them.
It's okay, it takes that sometimes.
Yeah.
So what happens if someone, like, I mean, you know what happens to these engineers on site, tightening a lot of them? Does that affect it? Or?
Not really. No, they're just wasting their energy and they're tearing up the Tommy bar. Look at the end of that Tommy bar.
Yeah, I see.
Yeah, they're just tearing up the Tommy bar and they're tearing up the socket. All right, so if we got them all tightened, then we'll turn it back on and release it. All right, you can see them collapsing themselves back down, and you'll see them loosen up. Sometimes you got to give it a little help. All right, so now that we've got them all tightened, we need to move them around so we can detension, or we'll leave them in place so we can detension from here. But whenever you're moving the tools around, and I'll definitely show you here in a second, but it's easier if you get all the hoses off.
Okay. So take hoses off.
It's easier to get all the hoses off. Now, one difference between, say, Tentec and High Torque is our little link hoses have T-blocks built into them. And what we've done this for is we can unhook all these hoses and keep them linked together and put them in a bundle. And you can literally just pick the bundle up, throw it on your shoulder, and move to the next flange.
Okay.
With our competitors' tools, they've got a link hose that goes from port to port. And so you have to unhook all of those and carry a bundle of hoses with you. You know, this one right here is just a roll like a water hose. You can just throw it on your shoulder and walk away. All right, so detensioning. You guys are the first ones I've actually been able to do this with. All right. So the rule of detensioning is you have to give yourself enough room to back the nut off, right? So what you want to do is you want to run your tool all the way down. Stop. When it stops, back it off one full turn. All right? So the reason you're doing that is you're giving room between the nut and the puller for you to relax the nut off the joint. So if you guys will do that, I'll grab these top ones right here. Just touch it down and then back it off one full turn. There we go. Wow. That one's already loose. All right. So, okay, you back it off one full turn on the puller. The other thing to keep in mind is 3 windows. Okay, so we consider that a window width, okay? So you're only gonna turn the socket 3 times to loosen it, okay? That should be enough to back it off to detension. All right, so I'm gonna bring it up to 500 bar. When detensioning is especially when you're gonna overstroke a tool, so that's when you really gotta pay attention and make sure we're not going too far, okay? All right, so I'm gonna pressure up. So now we're going to come in with our Tommy bars and we're going to loosen the nuts. 3 windows. All right. And the reason why we back it off a full turn, but we're only backing it off a little bit on the nut is we're making sure we don't set the puller down on top of the nut, because that's a common mistake when you're detensioning. And I've got a tensioner over here. I'll show you here in a second.
You can move this up, the hose, if you're in
Is the hose in the way? Not while it's under pressure.
Yeah.
You'll have to release pressure. So
Okay.
can we?
That one's a bit,
Let me see it real quick. We might be able to pry it.
It's not ideal to go against
No, sure it isn't. Let me see it real quick.
it. Go from that side too. It's not
Might be able to. We had a Tommy bar that wasn't all rounded off. It'd be okay. Yeah, we may have to do something a little different here.
This one's tight.
Yeah, I get it.
There you go. Wow, that must be. That's already pretty loose, actually.
Yeah.
Looks like it's already pretty loose.
This one is
It's hard to get to.
yeah.
Oh, good, don't worry.
You got it? Yeah, some of these may be. That one may be loose already too. All right. All right, so everything's clear. We'll go ahead and pressure it. We'll turn it back on and depressure. All right. So now,
It should be loose.
yeah, we're loose there. Is that one loose? Yeah, that one's loose. That one's loose. As long as we can get the pullers off, we're good to go. All right? So that's it. So now we need to move them, right? So we're going to pop all these hoses loose just from the tool. Okay? And it'll all coil into one bundle. There we go. And if you'll unhook that one right there for me, Alan. All right. And then you'll see what I mean. You can just literally grab these and put them on your shoulder and walk to the next flange, okay? All right. So now we're gonna move the tools. So remember, get your thumb in there. And back it off just like that. Yeah. And then what you do is you take off the first 2 and you set one to the side. Yep. And then now we're just going to go every other one. So we're going to move this one to here and so on and so forth. Some of these might already be loose. We had, yeah, that one's like super loose.
So should you put it on?
Yeah, go ahead and put it on there, just for the visual, I guess. You may have to hold the nut on the backside.
That's a loose one, yeah, as well.
What's that?
That's a loose.
Yeah, that one's loose. Yeah. Is this one? This one feels like it's still tight.
Yeah.
Yeah.
Leave it on.
That's all right. I'll detension it here in a second when we're done. But yeah, so we'll move that one to there and this one to there. Let's go ahead and do that just for the looks, and then we'll call it good. And then I'll detension the other ones without you. And that's the other thing with these, with that bridge pops off.
Yeah.
If you get it turned just right, it pops right off. So. All right. Voila.
Yeah.
Now you notice on these, like the cylinders are sticking up a little bit.
Yeah.
A lot of times we'll just turn the pump on and just manually wind them down if they're giving you trouble. And it happens from time to time. So, all right, you guys feel comfortable with it?
Good. Thanks very much.
Thank you.